Hi and hello dear friends, welcome back once again to our channel Vage Academy of Mathematics. We will see concepts which are related to UGC NET paper 1 mathematics and aptitude part, and following that here this session again we are going to see concepts which are related to another important topic which is calendars. And when it comes to calendars, we have two basic things with which only we can always start this topic. So those two concepts are going to be the concept of odd days and leap year. So these two things are what here this session we are going to see. Yes, we go. Now what do you mean by odd days, or how can we calculate the number of odd days? So the concept of odd days is going to be very simple. See here. So if we have a collection of days, then after forming some complete weeks, then how many days we have left over? That is how many days we have remaining. That remaining number of days is what we call it as odd days. That's all. Okay, fine. So for example, we'll just take these numbers and we will try to find out how many odd days we can form using these number of days. Right? Okay. Yeah, let's see them one by one. 10 days. That is, if we have 10 days, how many weeks we can follow with using those 10 days, that we have to think. Okay. We already know that 1 week is equal to 7 days. Right? So that means using 10 days, we can surely form one complete week, correct? So that means after forming that 1 week, we will be just erasing, or we can just eliminate those first 7 days, right? Because we have formed a one complete week using those first 7 days. So remove them. So how many days we have left over? 10 minus 7. We do that. We get 3 days. So that means for 10 days, we will get 3 odd days. Is the logic clear? Is the point clear? This is how we form odd days. Okay. So take the collection, take the total number of days, try to find or try to form number of complete weeks you can do, and remove those days, and then see how many days we have left over, how many days we have remaining. That tells how many odd days we have. That's it. Okay. Yeah. With the same logic, we will try to fill the other answers also. Take here 15 days. So for 15 days, how many odd days we will have? Okay. So with 15 days, think how many weeks we can form. Maximum how many weeks we can form. This is how we can think. Okay. So we'll have to frame or form maximum number of possible weeks we have to form. That is more important. So for 15 days, we can form 2 weeks. Is it or not? Because 2 7s are 14 days, right? So that means we can form 2 complete weeks, and that means we will be left with how many days in the remaining? So from 15, 2 weeks, 14 days are gone. That means 15 minus those 14, if we do, we'll end up with only 1 day. That means for 15 days, we will have only 1 odd day, right? Okay. But see here, if we have some big numbers going on, we may have some confusions when we are doing this calculation. Okay. So to avoid this, we can even achieve our answer by doing division process. Very simple. How can we do it by division? Let's see here. Let's take the same 15. Okay. Just do the thing through division. Just calculation. That's all. Okay. Let me show it by division. Take this 15. Okay. 15. And try to divide this 15 by 7. Because we are just taking 1 week, right? For each week we will have 7 days. That means 15 divided by 7. We'll do this division and let's see what happens. Okay. 7 1s are 7. 7 2s are 14. Is it or not? So 7 2s are 14. So that means what is the remaining? The remainder will be 1, and this remainder will tell you how many odd days you have. So that means what you can do is simply take the collection and divide it by 7. Whatever remainder you get, that remainder tells how many odd days you have for that number of days. Very simple. And there's nothing to worry about what quotient you are getting. And this quotient will represent the number of weeks formed, but that doesn't affect our calculation. All we need is only the remainder, because that remainder only tells how many odd days are there. Fine, okay. So let's try to finish the other calculations also. For 46 odd days, again we'll do it by division itself. Okay, we have some free space here, so 46 we will take, because 46 days we are given. So divide 46 by 7. So again just come out with 7 tables. 7 4s are will give us 28, right? 7 5s are 35. 7 6 are 42, but 7 7s are will give us 49. 49 will be exceeding this 46. So stop with 7 6 are 42. Now take the remainder. So 46 minus 42 we do here, we will get 4. So that means for 46 days we will have 4 odd days. So kindly do this division, and more important thing is we are dividing by 7. So that means we must be very sure with 7 tables. That is more important. Okay. So kindly revise it. And yeah, we have 2 more, 21 days. Let's divide 21 and see. Okay. So 21 we will divide it by 7. So we know 7 ones are 7, 7 twos 14, 7 threes. 7 threes will give us 21. So that means we will get the remainder to be only 0. So that means for 21 days there will not be any days remaining. That means for 21 days there will be only 0 odd days. Is the point clear? Fine. Okay. So if there's no remainder, I mean if the remainder is 0, that means odd days is also 0. That's all. Next we have 83. Okay. 83 we will see. I'll just take this space once again. Okay, I'll erase this. So for 83 days, let's see how many odd days we have. Again 83 we have to divide by 7. If you are comfortable, we can go with higher tables, but if not, we can do it step by step. Do it like 7 ones are 7, balance 1, take this 3, put it down. So we have now 13. So once again, if we go with 7 tables, we will get 7 ones are 7 only. So 13 minus 7 will give us finally the remainder to be 6. So that means for 83 days, we will have 6 odd days. And this is how we find the number of odd days for a given number of days. Now next is about leap year and a non-leap year. So basically, what do you mean by a leap year? And what is a non-leap year? That is what we have to see first. Basically, an ordinary year or a non-leap year, what we call, will have 365 days. Okay, for the entire year, we will happen to get 365 days, and those years are what we call it as non-leap year or ordinary year. But what do you mean by a leap year? A leap year will have extra 1 day. That means a leap year will have 366 days. So one extra 1 day that we can see as February 29th. Right? So not all years will be leap years. We have some specific calculations to check whether a year is leap year or not. With that is what we will conclude whether a given year is leap year or a non-leap year. Okay, fine. That is what we are going to see now. Yeah, let's see here. We have few examples. I have just listed some years here. Now we will see how can we conclude whether a given year is leap year or a non-leap year. Okay, for which we have 2 categories here. I will tell about that later, but we will start to examine whether it is a leap year or not. Okay, let's do it one by one quickly. The process is going to be very simple. Fine. Yeah, come start here. The year 2016. So I am going to check whether this 2016 is a leap year or a non-leap year, or I can say ordinary year. Fine. For which what we can do is make the process very simple, very easy. Just see the last 2 places alone. So in this 2016, we have the last 2 places to be 16. Now check whether this 16 is divisible by 4 or not. So we need to check with 4. Okay. That is going to be the test for the divisibility. I mean to check whether a year is leap year or not. All we need to do is we need to check by division 4. This is what we need to check. So take the last 2 places 16 and see whether 16 is divisible by 4 or not. We can very easily say 4 tables. 4 4s are 16. So that means 16 is divisible. Is it or not? 16 is divisible by 4. That means sure our year 2016 is a leap year. That's all. Very, very simple. Fine. Okay. So take the year and especially take the last 2 places alone and just see whether it is divisible by 4 or not. You may ask, why don't we divide the entire number 2016 by 4? See, actually, it is equivalent to divide this entire number 2016 by 4 only. If we just take the last 2 places alone. Okay. So that speciality that 4 has got, because if I want to divide a number by 4, I can even just take the last 2 places. That is enough. It is equivalent to divide that number, entire number by 4 is and see the remainder. Okay. You can even check with other examples and verify this. So anyways, 16 we are dividing by 4, it is divisible. That means now we can confirm 2016 is a leap year. Fine. Yeah. Take the next example, 1972. Again the same thing. See the last two places. We have got 72 here, is it or not? So now again we have to check whether this 72 is divisible by 4 or not. Again remember, forget about the first places, okay? What you have before this 72, this 19, here we have 20, forget about them, okay? As of now, there's nothing to worry about the first, the previous digits what we have. Just take the last two places alone, that's it, that's all, that alone is much enough, okay? So take this 72 and we have to check whether this is divisible by 4 or not, okay? For which I can divide by 72, divide 72 by 4, this I can do, okay? I will just show you by the shortest way possible, you can do it elaborately, okay, for your verification. I will show the shortest way possible and I can say that 4 into 18 times will give me 72, that means the remainder is 0. This means, once again I can confirm that 72 is divisible by 4, is it or not? Because since this is divisible only, we are getting remainder to be 0. If it is not divisible, we may get some other remainder, except 0, like 1, 2, 3, we'll get remainders like that. That will say that the number is not divisible by 4. Here we get remainder to be 0, so confirm, sure, our number 72 is divisible by 4. So that means, again, the year 1972 is going to be a leap year. Okay, understood? So very simple thing and very clear. Take the number and check dividing by 4. If it is divisible, it is leap year. If it is not divisible, it is not a leap year. That's all. That's how we concluded. Okay. Now come to the next example. We have 1854. As usual, just take the last two places. So here we see 54. Is it or not? So for 54, I can just divide it by 4 and see. Okay. So I'll just make a line here so as to avoid confusions. So 54 I'm dividing by 4. Again, I will do the calculation the shortest way possible. So I know that 4 13s are. So 4 13s are, I will get 52. That means here I will get a remainder 2. So this says this 54 is not divisible by 4. That means 1854, this year is a non-leap year. Do you understand? The first two cases we got it to be divisible, so leap years. But here this case it is not divisible by 4. That means it is a non-leap year, or I can say ordinary year. Okay, both are same only. We can call either as non-leap year or an ordinary year. Both are equivalent only. Okay. Yeah. Come to the next one. Here we got 1947. As usual, take 47 alone, and we'll just check it. So 47 we will just divide it by 4 and see what happens. Again, I will do the shortest way possible. So I know 4 12s are, or 4 11s are 44. I can go up to 4 11s are 44. This will again give me remainder as 3. So this is again confirming that this number 47 is not divisible by 4. That means this 1947 is again a non-leap year. Okay, fine. And one more thing I just want to reveal here itself. See this number 1947. By looking this number itself, we can very easily confirm that this is a non-leap year. You may ask why. See here, it's very simple. 1947. See the ending digit. Ending digit is 7. Is it or not? So this means this number is going to be surely an odd number. So no way an odd number will be divisible by 4. With that itself, that basic logic itself, we can very easily say that 1947 is an odd number. So that means it cannot be divisible by 4. It is not divisible by 4. With that itself, we can say that it is a non-leap year. So this conclusion you can always keep it in your mind. If the given year is a odd number year, okay, if you see that ending digit is an odd number. Odd numbers are 1, 3, 5, 7 and 9. So if your ending digits are going to be any one of these odd digits, sure, without dividing itself, we can say they are going to be non-leap years only. Okay. Yeah, fine. We have one last example, 2038. Again, we see the last two places we have 38. So divide 38 by 4. Here we have 4 9s are 36. So again we get to have a remainder. Remainder is 2. So that means once again we can confirm that this 38 is not divisible by 4. So that means we can again conclude this is also a non-leap year. Okay, fine. Yes. Now if you see these first 5 examples, all these left hand side things, all you can see is these numbers. You can see the last 2 places, especially if you see, you have those numbers to be ending with 0 0, without 0 0. Okay, it is ending with without 0 zeros. Fine. So if you see all these numbers, they are not ending with 0 zeros. So if the numbers are not ending with 0 zeros, what we are supposed to make this calculation? What if you have the years where the numbers are ending with 0 0, I mean double zero, ending with 0 0. Okay. Now these types of years if you are given, then how can we perform the calculations? That is what we are going to see now. See here, that is why I have just made two columns. Years ending without 0 0, these years. But what if years ending with 0 0, I mean double zero. Okay, that what we are supposed to do, that we do now. Okay, fine. So take these years now. The first year is 2000. Now it is very clear that the year 2000 is ending with double zero. To be precise, it is ending with 0 0 0. I mean 3 zeros it is ending with. But as per our condition, it is ending with double zero. Just see whether our year is ending with double zero or not. Okay, fine. Yes. So sure it is ending with double zero. So that means what we have to do is just eliminate the double zero, or just remove the double zero and see the remainder value. I mean the remaining value what we have. Now the remaining, if we see here, we can see the number 20. Is it or not? We can see the number 20. Now we are supposed to check whether this number 20 is divisible by 4 or not. This is all we have to check now. Okay. So I'll just erase this. So 20 is divisible by 4 or not. We can very easily say 4 5s are 20. That means this 20 is sure divisible by 4. So that means this is again a leap year. Do you understand this? Okay. And try to understand the difference between these two columns. Okay. I mean these two varieties. What if the year is not ending with double zero? And what if it ends with double zero? We have a clear difference. Okay. If it is not ending with double zero, just take the last two numbers alone. Divide it by 4 and then conclude. But if the year is ending with double zero, then reject that double zero and see what is there before that double zero. Here in this example, we have removed this last double zero, right? And we have got this 20 here. This 20 we are checking by 4. 20 by 4 we are just checking. We know that 20 is divisible by 4. That means it is a leap year. Okay. Understand the difference? Yeah, we follow here. Again, the year 1200. Now here again, this year is also ending with double zero. No doubt, just remove that double zero. And all we can see now is this number 12. Just check whether the 12 is divisible by 4 or not. So 12 divided by 4. I can very easily say 4 3s are 12, right? So that means this 12 is also divisible by 4. So that means this year, given year, is also a leap year. Okay. Let's go quickly. 1500 or 1500. Again ending with double zero. So just remove the two zeros and see the number 15. Only that 15. Okay. Now check whether 15 is divisible by 4 or not. 15 is a very small number only, right? So very easily we can verify that. 4 3s are 12. Is it or not? So 4 3s are 12 says 4 4s are 16. So 15 is not divisible by 4. That means this year 1500 or 1500 is again a non-leap year. Okay. So the condition is going to be the same, but which digits we take, that matters. Okay. So without 0, take the last two digits. With 0 0, take the zeros, take the digits except the last two. Okay. Yeah, next we have 2400 or 2400. Again remove 0 0. We have got 24 here. So 24 very easily we can say 4 6 are 24, right? So this is again divisible. So no doubt this is again a leap year. Next we have last one more 1900. So again do the same thing, 0 0 removed. So we have got 19. So 19 is not divisible by 4. Is it or not? Because we have 4 4s are 16. But 4 5s are will give us only 20. So that means 19 is in between, right? That means this 19 is also not divisible. So we can conclude that the given year is a non-leap year. So all the things we have to keep in our mind is, if the year is not ending with double zero, without double zero, sure take the last two places alone and you just divide it by 4 and see. If divisible, it is leap year. If not divisible by 4, it is not a leap year. And come here, if the year is especially ending with double zeros, remove the two, the ending double zeros and see what is left over. What is there previously to the two zeros. Okay. Take those digits. Okay. And check whether that number, I mean that value, the resultant value is divisible by 4. If divisible, it is leap year. If not divisible, it is going to be surely a non-leap year. Okay, this is all we need to remember under this leap year and non-leap year conditions. Okay, fine. And last one more thing I just wanted to give here itself, because it will be very useful when we do problems from calendars. Okay, that's the thing I just wanted to give here itself. See here, non-leap year, we know that 365 days, and leap year is having 366 days. Okay, this is how we started this one. And one more thing we just want to calculate here itself, what it is just now we saw about odd days, right? So that odd days also we can find for non-leap year and a leap year. Okay, we very well know that an ordinary year or a non-leap year we will have 365 days. Is it okay? So for 365 days, let's try to calculate how many odd days are there. Okay, I can even just do the division here in this left hand side space and then show you. Okay, so 365, for which we need to find the odd days. How we find the odd days? Just now we did, right? Before this, seeing this leap year, non-leap year only, we saw that odd days, right? So to calculate odd days, what we are supposed to do? All we need to do is just divide our number by 7. Whatever is left over, that is what tells us how many odd days are there. Okay, anyways, we'll do it here. 7, I'm just 365 and dividing by 7. So we will get 7 5s are 35, and we will have 1 here. Bring that 5 here down, and we have 15 now. Again, go for 7 tables. 7 1s are 7, 7 2s are 14. So we have 1 to be left over. That means 1 odd day we will have. Okay, that means for an ordinary year or for a non-leap year, we will have only 1 odd day. And what about this one, leap year? Leap year has 366 days, right? Okay, so now we will do 366 divided by 7 and see what happens. Same kind of division, 7 5s are 35, and now we will have 16, and again we can go with 7 2s are 14. Now I will have 2 as the reminder, so that means for a leap year we will have 2 odd days. So kindly and strongly remember these two things. They are going to be very important when we try the problems. For a non-leap year, for an ordinary year, we will have only 1 odd day, and for a leap year we will have 2 odd days. Okay, these two things we must strongly remember. This is much important for us. Finally, one thing I wanted to deliver you. You may wonder why we need to do these kind of calculations, or why we need to undergo this divisibility by 4 test, why it should be divisible or why it should not be divisible, to confirm whether a given year is leap year or not. But to answer this question, we will need the help of other subjects also, like astronomy. We need the help of history, we need geography, and we may even involve religious concepts for this. Okay, so all these are needed to answer those questions. If possible, we'll try to have a separate session for that, explaining the whole concepts of leap years and how it is formed, all the things. Okay, but for exam point of view, knowing up to this extent is more than enough for us to crack the questions in exam. Fine? Yes? Yeah. In our upcoming sessions using these concepts, we'll try to solve the problems. See you soon there. Thank you so much.